Hello everyone, welcome back to Research for Beginners. Many students struggle with research, not because statistics are hard, but because sampling is never explained clearly. In this video, I will explain sampling methods step by step, using simple language and real-life examples. By the end of this video, you will clearly know which sampling method suits your research and why. Let's begin. But before we start, please subscribe to our channel, like this video, and follow us for regular updates. Let's start with the most important idea in sampling. The goal of sampling is not to collect the largest sample, but to collect a representative sample. A representative sample means that your sample should reflect the characteristics of the population. For example, if your population has 60% males and 40% females, different age groups or departments, your sample should reflect these proportions as closely as possible. A small but well-selected sample is much better than a large but biased sample. Probability sampling means every individual in the population has a known and non-zero chance of being selected. Why is this important? Because probability sampling allows us to calculate sampling error, use statistical tests, generalize results from sample to population. If your research aims to publish in good journals or make policy recommendations, probability sampling is preferred. There are 4 main types of probability sampling we commonly use: simple random sampling, systematic sampling, stratified sampling, cluster sampling. Let's understand each one with easy examples.
In simple random sampling, every individual has exactly the same chance of being selected. Imagine you have a list of 1,000 students. You want to select 100 students. You can use a lottery method or use a random number generator in Excel or SPSS. The key idea is no bias, no preference, no pattern. This method is simple, but requires a complete list of the population, which is not always available. Systematic sampling is easier and faster than simple random sampling. First, you calculate K, where N is population size, N is required sample size. For example, population is 1,000 customers, sample size 100. K equals 1,000 divided by 100 equals 10. Now you randomly select a starting point, say number 3, and then select every 10th person, 3rd, 13th, 23rd, and so on. This method works well when the list has no hidden pattern. Stratified sampling is used when your population has important subgroups called strata. Examples of strata: gender, age groups, departments, education level. First, you divide the population into strata. Then you take a random sample from each stratum. For example, 70% undergraduate students, 30% postgraduate students. Your sample should follow the same proportions. This method is excellent when representation of all groups is critical.
Cluster sampling is useful when the population is large and geographically dispersed. Instead of selecting individuals, you select groups or clusters. Example: population, students across the UAE. Clusters, universities or schools. You randomly select a few universities and survey all students within those universities. This method reduces cost and time, but sampling error can be higher than stratified sampling.
Multi-stage sampling combines 2 or more probability sampling methods. Example: Stage 1, select cities. Stage 2, select schools within cities. Stage 3, select students within schools. This approach is very common in large national or international surveys. It provides flexibility while maintaining randomness. Non-probability sampling means not everyone has a known chance of selection. These methods are faster, cheaper, easier to implement, but they limit generalization. These methods are often used in exploratory research, qualitative studies, pilot studies. Convenient sampling means selecting participants who are easy to access. Example: surveying students in your own class, asking people in a shopping mall. This method is quick, but it introduces high risk of bias. In purposive sampling, the researcher intentionally selects participants. Example:
interviewing CEOs for innovation research, selecting policymakers for governance studies. This method is common in qualitative and case study research, where expertise matters more than representativeness.
Snowball sampling is used when the population is hard to identify or reach. One participant refers another, and the sample grows like a snowball. Example: women entrepreneurs, migrant workers, informal sector participants. This method is powerful, but highly non-random.
Quota sampling ensures that certain characteristics are represented in fixed proportions. Example: 50% male, 50% female. However, selection within each group is not random, which limits statistical generalization.
Let's summarize. Sampling allows us to save time and cost, reduce data collection burden, make accurate generalizations. A well-designed sampling method is essential for valid and credible research. Always remember, good research starts with good sampling. Which sampling method is best for your research? You can ask us in the comments. Now, I want you to think. Which sampling method suits your research topic? Is your study exploratory or confirmatory? How can you reduce sampling bias? Share your answers in the comments and we'll help you choose the right sampling method. If this video helped you understand sampling clearly, don't forget to like, share, and subscribe to Research for Beginners. Tell us in the comments which research topic you want us to explain next. See you in the next video.